Good day, my well-esteemed viewers. You are welcome back to my channel. Previously, we have talked about reactions of alkanes. We also talked about reactions of alkanes. Today, we are going to have a look at reactions of alkynes. Alkynes. Remember, all of them are under the topic organic chemistry. Now, alkynes are hydrocarbons that have the general molecular formula CnH2n-2. They also have triple bond, meaning they are highly unsaturated. Unlike alkenes that have double bond, alkynes have triple bond, meaning that they are highly unsaturated. And they end with YNE. So, three things. One, they have triple bond, meaning they are highly unsaturated. Two, they conform to the general molecular formula CnH2n-2. Then they end with YNE. So, since you have a knowledge of that, let us have a look at the chemical reaction of alkynes. So alkynes, since they have triple bond, for example, the simplest member of the series, they also have their homologous series. You have their series, you have ethyne, propyne, butyne, like that, and so on, pentane, and so on and so forth. The simplest member is ethyne. You have it in this format. Remember, I told you in the first video that carbon is tetravalent, meaning it has 4 bonds, must always be combined with 4 bonds on each side. So this is ethyne. This is the one we are going to use for the reactions. However, you can also use other members of this series. The major thing is that you have a triple bond in between 2 carbon atoms. This one is easier for us to use for chemical reaction because as the number of carbon atoms is increasing, it starts creating resistance. So we use this. So the first one, but remember also, it's a hydrocarbon, so it can undergo combustion. Combustion, as I said before in the previous video, is burning in oxygen to produce carbon dioxide and water. So let's see the combustion first. Combustion reaction of alkyne, e.g. ethyne, which is the simplest member. You have C2H2 plus O2 to give you CO2 plus H2O. This is the first reaction. Now you have 2 carbon atoms. You must introduce carbon here, 2 hydrogen is already there. Now let's calculate the amount of oxygen. You have oxygen, 2 times 2 is 4 plus 1, 5. You put 5 over 2 here, meaning that this one is a fraction can cancel out. But you cannot usually, even if you leave it like this, correct? But you cannot usually leave it like this because most of your books don't have this type. Therefore, you multiply throughout by 2 times 2. Become 2C2H2 plus these 2 will cancel out 5O2 to give you 4CO2 plus 2H2O. This is the equation for combustion. Remember, correct reactant and product, don't ever forget that. 1 mark, then balancing the other mark. So this one is a combustion reaction you see in many of your books. However, this is how it was arrived at. There are so many ways they can arrive at it, but this is the one I choose to use. So that is how it is. Then let's go to the other reactions. Addition reactions. It undergo more addition reactions than alkene. So let's say addition reaction. Reaction 1. Addition of hydrogen. Let me just put, okay, let me spell it out. We call it hydrogenation. For example, you have, let us use the structure. It makes it easier for us to comprehend it easily. You see, we said this alkyne, ethyne. If you add hydrogen, you have C double bond C. 2 hydrogen is needed to remove 1 bond. So you have a compound like this. So you can see you have 18. You see it. This 18, you still have double bond. So you have not completely removed the unsaturation. Then you can also add another hydrogen. It now becomes a fully saturated hydrocarbon with single bond in all the skeleton. This 18. So it means we converted ethyne to 18 and finally to 18. This is one of the reactions. Because we use hydrogen, we call it hydrogenation. However, it's not compulsory that it must be hydrogen. We can also use halogens. There are so many reactions. We are going to discuss few of them in this video. Subsequent video, however, we can include others. Addition of halogen. Depending on the halogen you are using. If you are using e.g. chlorine, we call it chlorination. Bromine, bromination. Let's see how that one goes. C triple bond C. Triple bond between two carbon atoms, not between carbon and hydrogen. Plus Cl2. You have H to C, double bond C to H. You also have chlorine here. You have chlorine here. You can see it. This 1, 2, di. There's a hyphen before the word. 1, 2 di chloro 18. From ethyne to 1, 2 dichloro 18. We are not satisfied here. We can further increase the halogens. See, remember, if you are using one halogen, use that type of halogen throughout. Not using chlorine, then using bromine is not allowed, because they all have different, they all undergo different reactions. So under different conditions. So if we add this, we now have to C to Cl, a fully saturated hydrocarbon. However, it now has 4 halogen. You see it. So this one becomes 1 up, 1 down, 1, 2, 2 up, 2 down, tetra chloro 18. So it's not saturated hydrocarbon. This is the second reaction, and this one covers the other halogen. The same method, you get the similar product, just the name differs. Then the last one we are going to consider, the last reaction we are going to consider is the addition of hydrogen halide. Remember, we undergo polymerization and others, we are not considering them in this reaction. Subsequent reaction, we'll talk about them. Addition number 3 of hydrogen halide can be let's use hydrogen bromide. So we see it, H to C triple bond C to H plus HB arrow. You see it. When you undergo this reaction, you have H to C double bond C to H. You have B arrow. You have H. This is the product you have. Remember, instead of using 2 hydrogen atoms or 1 hydrogen molecule, you have added something else. There are still 2. You need 2 of these elements or atoms to remove 1 bond. So having this, we know this ethyne, this bromo 18. Please, you should not be confused about this. In some of your examination bodies, what they normally do, especially where some of your examination bodies, what they normally do, if you have bromo 18, they can put 1 bromo 18, it's still the same thing. It's just like somebody having X and the other one having 1X. They are similar. They are the same, no similar, they are all the same thing. So if you have 1 bromo 18, it's the same thing as bromo 18, because I've seen some of those past questions, they usually use 1 bromo 18, but the real name, instead of writing 1S, we can normally write S. Both of them are correct. So we add another hydrogen bromide to this, HB arrow. I'm telling you about life questions. So you have H to C, double bond, single bond, C to H. You have bromine here. You have hydrogen. You have hydrogen. You have bromine. Because according to Markovnikov rule, this is how it should be. So because the halogen will attach itself to that hydrogen, that part of the carbon atom that have the least number of hydrogen atoms. So you have it like this. This one is 1 dibromo 18. So this is the addition of hydrogen bromide. Please, there are other videos that will also bring along as time progresses. One thing we always appeal to you, I always appeal to you, my amiable viewers, highly esteemed, please always do well to subscribe. I need a lot of subscription to keep this channel going. God bless you. I will meet in the next video.